Hello everyone. In the last class, what we have discussed? We have discussed about the circular motion. Okay. Circular motion. What is circular motion? If a body is moving around a circular path or circular track with uniform velocity. Okay. If a body of certain mass is moving in a circular track or path with uniform velocity, then the body is said to be in circular motion. Okay, suppose the body of mass is moving in a circular path of radius r, then it is said to be in circular motion. And during this, what we discussed about the centrifugal force. Centrifugal force and centripetal force. This away from center, it is towards the center. Okay. And while discussing centripetal force, what I have discussed that the cause of centripetal force. Okay. In different systems, what are the cause of centripetal force? That we have discussed in the last class. Okay. Like when you rotate a stone by suppose you have tied a stone with a string or rope and rotate in a circular path. Okay. You have tied up a stone with a string or rope and you rotate it in a circular path. Then what is the cause of centripetal force in this system? It is because of the tensional force. Okay. Or it is due to the tension that it is the centripetal force is because of the tension in the rope. Similarly, in case of our solar system, this sun and Earth is moving around this sun, this is Earth, and here the centripetal force, okay, is due to the gravitational force, okay, between sun and Earth. Similarly, in case of car, okay, in case of a car, suppose a car is suppose a car is moving in a circular track, so here the car can move or car can take turn in a circular track because of the presence of centripetal force. And in this case, what is the cause of centripetal force? It is exerted by the force of friction between the wheel and the road. Okay, this is actually the front side of the car. Okay, these are two wheels. Okay, car is moving in this way. Okay, so this thing we have discussed. These are the cause of centripetal force in different systems. Now, one thing I discussed that last class, banking of roads. Okay, this thing we have discussed. I have not completely discussed this thing in last class. During banking of roads, we have considered two systems. Okay, first system is a car is moving a circular track where the circular track is planar. Okay, the car is moving a circular track, but here the track or this road is plane. Okay, planar road. Okay, and second case, what we have considered, a similar case, a car is moving in a circular track or car is taking a turn in a circular track, and here the what are the conditions? Here track is not planar, it is tilted or it is or we may say that the edge of the road is lifted. Okay, edge of the road is lifted, okay, up to certain angle. Okay, that is, this road is not planar like this. In this case it is inclined. Okay, it is inclined at some angle. Okay, this inclined with the center, this road is inclined at the center with some angle. Okay, so these are two cases considered. Okay, this is the front side of the car is moving like this way. Okay, so in planar case what we have calculated, we calculate the maximum velocity at which this car can take the circular turn. Okay, and we have found that mu is equal to mu is equal to r z. Okay, mu is the limiting mu is the coefficient of static friction, r is the radius of the circular track, and g is the acceleration due to gravity. This is the maximum velocity at which the car can move or car can take turn in the first system, or that is the plane road. Okay, and now we discuss the second case. Okay, that is in case of a banked road. Okay, so this is second case. So suppose I am drawing this. Okay, the second case, suppose this is a road. Okay, suppose this is a road. Okay, and there is a car moving in this road. Okay, this is the front side of the car. There are two wheels. It is facing outward. Okay, the car is moving outward the plane of the board. Okay, and this is the cross section of the road. That is, the road is banked, or it is inclined with the center at an angle theta. Okay, so see, so the system is like this. Okay, there is a road. Okay, is banked or inclined with the center. The road is inclined with the center with an angle theta, and the car is moving in this way. Okay, like this. Okay, this is the system, and I have drawn like this. So what are the forces is applied on this car? Okay, first force is acceleration due to gravity. Suppose mass of the car is m, is mg. Then second force will be normal force. Okay, I'm adding this n. And what is the third force? Then next force is the frictional force. Okay, what is the direction of frictional force? See, when the car is moving in this circular track, it will experience the centrifugal force. Okay, away from the road or away from the center of the circular track. So centripetal force will be towards the center. Okay, and in this system the centripetal force is exerted by the force of friction. Okay, so frictional force will be in this direction. Okay, this is the direction of this is the frictional force. Okay, frictional force between the wheels of the car and the road. Okay, it will be in this direction. So now we have the forces that is applied, or force, the system will experience force which are weight of the car. Okay, gravitational pull, then friction force, then normal reaction. Okay, now we have to resolve the components. Okay, of this force. See, for solving the problems in mechanics, we have to, in maximum cases, we have to resolve the component of force. Okay, such that we can compare. Okay, we can like we had done in equilibrium of concurrent forces, we have to compare, make equations of the for the forces. Okay, so for this case I am resolving the component. So see, and normal reaction is perpendicular to the surface of the rule. Okay, so I have resolved into two components. Okay, this is what will be this component. See, this is theta. Okay, so this angle will be how much? This angle will be also theta. Okay, and this angle will be how much? 90 degree minus theta, and this will be also theta. Okay, so in this case, if you see, or if you see diagrammatically, what will be that angles? This will be theta, and this angle will be theta, and this angle will be theta. So now I'm going to resolve the components. This component will be n cos theta. Okay, this component will be how much? N sin theta. Okay, we have resolved the component of normal force. Okay, normal reaction. Now we resolve the component of frictional force. See, frictional force is along this direction. Okay, so the two components when we resolve will be, so see, the components will be perpendicular to each other. So one component will be in this direction and one component will be in this direction. Okay, so see, this component of friction will be Fr cos theta, and this component of friction will be how much? Fr sin theta. So what we got now after resolving, okay, after resolving a component of normal action and frictional force, what we got, that in this direction there are two components, okay, of force. One is normal, one component from normal action and another component from frictional force. And in this direction there are two forces: acceleration due to gravity, gravitational force, and another is one component of frictional force. Okay, so now see, the car is moving in its track. Okay, in forward direction. There is no movement of the car in upward or downward direction. So this force n cos theta will balance these two forces. Okay, this component of force normal reaction, this component of normal reaction will balance these two forces. So you can write n cos theta is equal to mg plus fr sin theta. Okay, so frictional force will be how much? We are considering a limiting case. Okay, so frictional force will be how much? Mu s to n. N is normal reaction and mu s is what? It is the coefficient of steric friction. So here we can write mg plus mu s into n sin theta. Okay, or if you take this term into left hand side, n cos theta minus mu s into n sin theta is equal to mg, or you can add n cos theta minus mu s into sin theta is equal to mg, or you can write n will be how much? Normal reaction will be how much? mg cos theta minus mu s sin theta. Okay, so this is 1. Okay, so normal reaction, okay, normal reaction on this car or on this system, sorry, normal reaction on this car is how much? N equal to mg by cos theta minus mu s sin theta. Okay, so I have put equation number 1. Okay, now I'll go for the second case. Okay, so I am writing here, I'm writing the value of n. N will be, n is how much? N is mg cos theta minus mu s sin theta, and I have given equation number 1. Okay, I am writing this. Now see, now I am going for the this component, okay, or force along this side. So see, centripetal force is what? It is along the center of the circular track. So the body or this car is experiencing a centripetal force due to these components, okay. Due to the force along these directions, this body or this car is experiencing centripetal force, okay. So what is the centripetal force? M v square by r is the radius of the circular track, will be how much? N sin theta plus fr cos theta, okay. Or in place of fr you can write mu s into n, or mu s into n cos theta. So m v square by r will be how much? If you take n common, sin theta plus mu s cos theta, okay. Or we can write the value or from equation 1 we can put the value of n in this equation, okay. So how much it will be? M v square by r will be mg sin theta plus mu s cos theta by cos theta minus mu s sin theta, okay. Now cancelling m from both sides. So from here what we do? We will isolate the v term, okay. We want the velocity term, okay. We want velocity, okay. That is velocity at the we want maximum velocity at which the car can take the turn in this bank road, okay. So from here we can obtain velocity. V square will be how much? G into r into sin theta plus mu s cos theta divided by cos theta minus mu s sin theta, okay. So this is the v square term. Now I am having this, okay. Now what will be the v? Okay, what will be the v? V will be root over gr, okay, root over gr whole over into sin, or we can write this gr sin theta plus mu s cos theta by cos theta plus minus mu s sin theta whole to the power half, okay. This is the value of v. See, this is the v max, okay. This is v max. That is in this case, that is in case of bank road, what is the maximum velocity that a car can take turn, okay. The car can take circular turn. What is the maximum velocity at which the car can take circular turn is this much in case of bank road, okay. Now what we do? We divide both numerator and denominator by sin theta. We divide both numerator and denominator by sin theta. So what it will be? I am writing like this: gr to the power half. Dividing both numerator and denominator by sin theta, it will give dividing both numerator and denominator by cos theta. Dividing both numerator and denominator by cos theta, it will give how much? So mu s will be isolated plus sin theta by cos theta tan theta. tan theta. Then here 1 minus mu s tan theta to the power half. Okay, so in case of bankrupt, what is the maximum velocity that the car can take the circular turn? Is gr to the power half mu s plus tan theta 1 minus mu s tan theta to the power 1 by 2. Okay, so this is the final expression what we get in case of maximum velocity for a bankrupt. Okay, this is the expression of velocity that a car can acquire in case of taking a circular turn where taking a circular turn in bank road. Okay, and road is bent at an angle theta with the horizontal. Okay, so this is the expression. So I am rubbing this thing, keeping the final expression. Okay, in earlier case what we get, in case 1 what we get, in case of plane road Vmax is how much? In case of plane road Vmax is root over gr mu s. Okay, in case of plane road, planar road, this in case of bank road. Okay, okay, so see, if we if the theta is 0, that is, if we put theta is 0 in this expression, this theta is equal to 0, theta is equal to 0 means the planar road. Okay, not bank road, planar road. If I tell what it will be, Vmax will be how much? Vmax is equal to tan theta, tan 0 equal to 0, this tan 0 equal to 0, these two terms will be 0, so it will be gr mu s to the power half. See, when we put theta is 0, then Vmax will be mu s r into g, so this is equal, this is similar to this term. Okay, so see, from there, from this expression, if we put 0 in theta, then we get the expression for maximum velocity in case of planar road. Okay, now see here, this is bank road. Okay, see this in case of bank road we can get, or we can take turn with maximum velocity. Okay, in case of planar road, what is the maximum velocity that we can take turn in circular road? It is this much. In case of bank road, what is the maximum velocity? This, and this term is greater than this term. Okay, so I am actually here I will give an example. Okay, so from here we can see that in case of bank road we can take circular turn with high velocity. Okay, so in case of safety purpose or so bank road is very useful, essential for making circular track. Okay, for making circular track we have to always bend the road. Okay, or we have to leave the edge of the road away from the center. Okay, so this is nothing for the increasing the Vmax value. Okay, so that we can take turn at maximum velocity, and here there the for the safety purpose actually. Okay, so now I am taking an example. Okay, suppose this case 1, this is case 2. Okay, suppose mu s is how much for a rod? I am taking an example for a surface. Mu s is 0.2. Okay, and theta is how much? Theta is 27 degree. Okay, so here see, here we find the value of Vmax in case of for these terms. Okay, So if in this case mu s is 0.2 and theta is 27 degree, so what will be the Vmax? Vmax will be how much? In case 2, Vmax will be how much? Gr to the power, suppose radius is r, okay, I am not giving the value of radius. So mu s is 0.2 plus tan 27 degree will be nearly equal to 0.5, okay. So 1 minus 0.2 into 0.5, okay. So it will be gr to the power half and 0.7, 1 minus 0.1, 0.9, 0.9 to the power half, okay. If you solve this, 9 by 7 to the power half, so how much it will be? 7 divided by 9, 0.5. So it will be how much? 0.88 gr to the power half, okay. So see, if the rod is bent at theta is 27 degree, then what is the maximum velocity or Vmax that we can take turn in that circular rod? It will be 0.88 into gr to the power half, okay. If there is no banking, okay, so and now I am taking this for planar rod, okay. So in case of planar rod, okay, this is the case 2, okay. In case of planar rod, this is case 1, so theta will be 0. So I am taking the second example, second case, mu is equal to 0.2 and theta is equal to 0 degree, okay. That is, the rod is planar, not bent. So Vmax will be how much? Vmax will be how much? Root over 0.2 into gr, and what will be root over 0.2? So it will be 0.44 gr to the power half, okay. C. So C. In case of bank rod, where banking of the rod or inclination of the rod is 27 degree, the maximum velocity will be 0.88 into gr to the power half. In case of planar rod, taking the same surface where the potential equation is 0.2, the same surface, if the inclination is 0 or banking is 0 degree, then what is the maximum velocity? 0.44 into gr to the power half. So see, if we bend the rod at 27 degree, we can acquire double of this velocity, okay. Okay, see. So see, in case of bank rod, what we get? 0.88 into gr to the power half. This is the Vmax, okay. In case of bank rod. And in case of plain rod, what is the maximum velocity? 0.44 into gr to the power half. Equal to Vmax in case of plain rod. In case of planar rod, okay. So see, if you compare both the values, this is twice of this one, okay. So in case of bank rod, okay, if the surface is same, okay, in case of bank rod, we can take the circular turn, okay, with twice the maximum value that we can take the circular turn is twice that of this planar rod, okay. So see, here in the bank rod, the maximum velocity that we can acquire to take the turn, the circular rod, take a circular turn is the maximum velocity of taking the circular turn in case of bank rod is twice as that of the planar rod in this case, okay. See, if theta is 27 degree, then we get 0.88 into 0.5, okay. If theta is 27 degree, it is twice as that of the Vmax value of the planar rod. So see, that is why banking of rod is very essential, okay, for safety purpose for diminishing the accident. Okay, so that if a car is moving at high velocity, the probability of keeping the car away from the road is minimum. Okay, in case of bank road, so that the probability of keeping the car away from the road should be minimum. Okay, that's why banking of roads in case of circular track is very essential. This is one example for your understanding purpose. Okay.